everyone. In this video, I'd like to talk about functions, and some of the properties that we'll look at are whether a function is onto and one-to-one. So first of all, let's take a look at the definition of a function. A function is a map that sends elements from one set, and we'll be very specific with what we mean there. That's called our domain. That's also known as your input or starting set. So a function is a map that sends elements from one set, our domain, to another set. And that other set is what we'll call our codomain. Now, to be a function, you have to satisfy two rules. The first rule is that every element of the domain must be sent somewhere. So I'll say every element of the domain, or our starting set, our input set, every element of the domain must be sent somewhere. In the codomain. And the second rule is that each element can only go to one destination. And let me share a picture of what I mean. So I'm going to draw my domain here in pink. This is my domain. It's my starting set. You know, when you think about you're the captain of your own domain, if you think about your house and you start in your domain every morning and you go out into the world from that set or from your house. So your domain is your starting set. And the codomain, that's going to be your target space. It's the set of all places you might go. All right, so something that's a function. A function, let's give ourselves a few elements here. I don't know, give ourselves 3 little elements. I'll call them element 1, 2, and 3. So a function has to send each of these items somewhere into the codomain. So 1 got mapped to some destination in the codomain. I don't care, call it X. I'm just making up letters so I can draw you a picture. Suppose that the number 2 got mapped over here to X. And suppose 3 got mapped over here to some other point, we'll call it Y. Now, is this a function or not a function? Well, a function is a map. It's a rule that sends elements from the domain to the codomain. So far, so good. Let's check our 2 conditions. The first condition says that every element in the domain got sent somewhere. And that's true. Everybody, 1, 2, and 3, everybody got sent somewhere. We didn't leave anybody out. So that's good. Criteria number 2. Each element can only go to one destination. Well, number 1 went somewhere and it only went to one spot. That's great. Number 2 went to somewhere and it went to one spot, went to X. And similarly, 3 got mapped to one element. So this is a function. That satisfies the definition of being a function. In contrast, if I drew you a different picture, here's my domain. I'll label it domain. And my codomain here, I'll label it codomain. In contrast, suppose I had 1, 2, and 3. And suppose that 1 maps over here. To X, and suppose that 3 maps over here to Y. This is not a function. This is not a function because I left out number 2. All right, let me do something a little bit different. Suppose I took number 2 and I sent the number 2 to x. Okay, that's a function. But suppose I also sent number 2 to y. That's also not a function because now the element 2 is being sent to 2 different places. You know, I always say it's like the Department of Motor Vehicles. If I go in there, tell me which line to go to. Map me somewhere, but don't map me to 2 lines. And that's usually what happens. I go to the Department of Motor Vehicles and I end up being told, go stand in this line and then go stand in that line. And it's very confusing because I don't know which line to go with. And that's what's happening to poor number 2. Number 2 doesn't know where to go. Is it going to go to X? Is it going to go to Y? A very confusing situation. So this is not a function because it doesn't satisfy that second criteria. Okay,